So did you think about it? Why do we, okay, I told you that we have dependency between attributes. So what is functional dependency? I told you this is just dependency between attributes. Okay, this is dependency between set of attributes to sets to set of attributes. So can anyone tell me why we use this word function here? Why this word function is used? Can anyone tell me? You know what is a function? Function is a mapping from one set to another. You already know what is a function. So what is a function? Function is basically a mapping, correct? So you can notice function is a mapping from one set to another. If you have a set x, if you have a set y, then this type of thing is called function. Okay, a b c 1 2 3 4. So this type of, you can notice this type of mapping, this type of mapping is called function. You already know what is a function. Now I am saying that functional dependencies, this is dependency between two set of attributes. So for example, I told you that if you have district, so if you already know what is the value of district, if I already tell you what is the value of district, then automatically you can tell me what is the value of Rajasthan, what is the value of state. Sorry, in my mind, Jaipur was going on. Okay, so you can notice if you know the value of district, then you automatically know the value of state. Okay, so the value of district determines the value of state. This is called, basically uh, this is called function. I can say determines. I can say this means determines. Okay, or I can say implies. Okay, so this is the point. So tell me now why this word we use function, why we use this word function in the functional dependencies. So we call that this is functional dependency. This dependency, we call it functional dependency. This is a dependency, this is a dependency, and actually we call it functional dependency. The word we use is functional dependency. So why we use this word function? This is my question. Yes, very good. Because you can notice we can map only to one value. Okay, so you can notice the why we use this word function, because you can notice any value that you take here, any value that you take here, okay, you can map to only one value here, yes or no? So you can very easily see that this is a function. This is actually a function, because if you know the value of, for example, if you know Jaipur, then in that case, okay, so this is your states, and in these states you can see, okay, so for example Rajasthan, you can notice, okay, for example you can notice, okay, Maharashtra, okay, or for example let's assume you have Mumbai, and so on. So for example maybe, okay, Karnataka, and here you have Bangalore. So like this, now you can very easily notice that you can never have this type of scenario. Okay, this implies this, I can say this implies this, what it means. So this is called functional dependency, because actually this is a mapping. This, okay, this dependency is called functional dependency because this is actually a mapping. Because if you know the value of district, then you can uniquely find the value of state. It can never happen like this can never happen. So you can notice if you know the value of a district, then you uniquely can find the value of state. Okay, so like this type of mapping you have, but you can notice this can happen, but you can notice that this can happen. For example, this can happen that, okay, if you have, let us assume quota, then in that case this can happen. So this is still a function, this is still a mapping. So you can notice this is still a function. The point is very simple, that okay, district implies state, and so this is the point. So you can notice if you know the value here, if I tell you the value of district, then you can uniquely find the value of state. Okay, so from the value of district, from the given value of district, we can uniquely, we can, this word is very important, we can uniquely, we can uniquely find, okay, we can uniquely find the name of state. So this is the point. So that is the reason we use this word functional dependency. Okay, so this type of dependencies are called functional dependencies. This we have already seen in the last class. Okay, now you can notice, let's see one more few things actually. So actually on your screen, what you are seeing right now, this this screenshot actually has been taken from the original paper of code. I told you that relational database. So this, I told you that relational model. Do you remember this? I told you that relational model, this was proposed by code. Yes or no? Yes, correct. This was actually proposed by Edward Ted Code. Okay. So this was proposed by Edward Ted Code. And I told you that this Edward Ted Code, he wrote a research paper basically. He wrote a research paper. So he wrote a research paper. He wrote a research paper. In this research paper, you have basically this relational model. So in this research paper, he described, he in this research paper, multiple research papers he published actually. Okay, so he okay, so this code, he wrote a research paper. In this research paper, he described relational model. He also gave the concept of, he also gave the concept of functional dependencies. So in this research paper, he also gave concepts of, basically described concepts of, so these concepts that we are studying, this functional dependency concepts. So in this research paper, he described the concept of, he described the concept, he described the concept of functional dependency. He also described the concept of uh, transitive, partial depend. There is something we will study, don't worry. Partial functional dependency, transitive functional dependency. So these concepts also he defined. So actually these concepts are given by code. All these concepts, the functional dependency concept, the relational model. So this relational model is given by code. Okay, you can notice. And the concept of functional dependency is given by code. Partial functional dependency, transitive functional dependency, trivial functional dependency, this trivial functional dependency, this non-trivial functional, all these concepts we will see, don't worry. So all these concepts are also given by code. Also the third point, for example, these concepts like 1NF, one normal form, two normal form, three normal form, these concepts are also in this research paper. So in this research paper, he also described, basically in this research paper, he also described these concepts. So these concepts, okay, we will study today, we will study these concepts today, we will study these concepts. But actually all these concepts and relational model we have already studied. So we have already seen what is a relational model. We need to see these things. Now you can notice all these concepts are actually described, all these concepts were given by Edward Ted Code. Okay, and the research paper, if anyone is interested, I can send you the research paper, the original research paper. This research paper was published in 1971. So in 1971, he published this research paper. Okay, and this screenshot is taken from the screen from the research paper. You can notice here basically he has defined the concept of functional dependency. Okay, anyway we have already seen this, but there is one interesting thing about this screenshot. Actually, from this screenshot, I you know, one interesting thing you can observe. So why I'm asking this definition? In the functional dependency definition, we have this word function. Why? Because very easily you can see that if you know the value here, then you can uniquely find the value here. So this is the concept of functional dependency. Now you can notice one thing very easily. You can notice what it actually says. So for example, what it actually says, it's like this. Let us assume you have a relation R. Okay, and in this relation R, let us assume you have A, B, C, D. Now you can notice in this relation R, consider this FD. Consider this functional dependency. A goes to A implies B. A determines B. What it calls, what we call it? We call it A determines B. So let us assume this is your relation. In this relation, you have four attributes A, B, C, D. This is the relation schema. This is called schema. And in this schema, we have this functional dependency that A determines B. So if you know the value of A, then you can uniquely find the value of B. Okay. So now, or let's take C implies D. So let's take C implies D. Now you can notice that. Okay, just tell me this point. Just tell me this point. Let us assume you have the. If you only take, okay, don't take all these things. If you only take C comma D, if we only take C comma D, if we only consider C comma D, if we only consider a table containing C comma D, containing C comma D. Okay. If we consider only a table which contains only these two, now okay, not these, only these two. So if we only consider a table containing C comma D, then what will happen? Then what will happen? So basically, this is C comma D, this table. Okay, if you consider only this table C comma D, then what will happen? So if you notice that, if you consider this relation R, okay, in this relation R, A, B, C, D. In this relation R, let us assume we have C implies D. Okay, let us assume this is one of the FD. Let us assume this is one of the possible FDs. Let us assume this is one of the FDs. Okay, now you can notice in this relation A, B, C, D, if this is one of the FDs, then you can notice this will happen. What will happen? So for example, if you have this 2 here, let us assume, and 2 here, then let us assume you have here, let's assume 11. Now you can notice, okay, you can randomly I am taking anything. So if I repeat this 2, then this 11 should also repeat. If I repeat this 2, then you can notice this 11 should also repeat, correct? So you can notice if I repeat this 2 again, then the 11 again should repeat, correct? Like this, yes or no? So you can notice here, okay, if you take only this table, okay, right now you can notice, okay, so 2 is mapping to 11, 2 is mapping to 11, 2 is mapping to 11. Now if I only project this C comma D, for example, let us assume 3 project, okay, 3 12, let us assume, okay, so let's assume this table you have. Now okay, what I'm asking that if you only consider the table, okay, if you basically take out only a C comma D, so this is your relation R. In this relation, this is one of the possible FDs. Let us assume this is the one of the FDs. Now I am asking, if you only project C comma D, if you only take out C comma D, so basically if you take out C comma D, this is called projection. This is known as projection. We will see this. This is known as projection. Okay, this is known as projection. Basically, we are projecting C comma D. Basically, we are projecting C comma D. This is what we are projecting. Means from this relation, we are taking this out. Okay, we are taking this out. These two columns we are taking out. So tell me, if I take out C comma D, then what will happen? If I take out C comma D, if I project C comma D, then what will happen? Then I will get 2 11 and 3 12. This is what I'm going to get. Yes or no? This is what I'm going to get. No, bijection is not, see, how can you get bijection? For example, consider this 4 and consider this 11, 4 comma 11. Bijection, how can you get bijection? Bijection you can get only when two way. Tarandeep, see here, every functional dependency is one way. I told you, every functional dependency is a function basically. You can notice, yes or no? Every functional dependency, this is a function actually. And function need not be bijection, yes or no? Every functional dependency is a function. You can very easily see that this is a functional dependency and this is just a function. And function need not be bijection. Function may be bijection, function may not be bijection. In this situation, you can notice this is a functional dependency and you can notice this is not a bijection. So what I'm asking is, so if you take out only C comma D, then this is what you are going to get. And this is actually a function, yes or no? So actually the point is very simple, that if you only take out this C comma D, then what you are going to get? Then you are going to get a function. Actually, this I can represent as a function. If you only take out this, then this I can represent as a function. So every functional dependency is basically, I can say, finally what I'm saying, this is the final point I'm saying. I'm saying that if you take out the functional dependency, if you take out C comma D, if you project C comma D, then you will get a function. That's what I'm saying. Similarly here, district comma state. If you only consider district comma state, if you only consider these two, if you only consider district comma state, then you will get a function. This is what I'm saying. Yes or no? Is this clear to everyone? So if you take out the functional dependency, if you project the functional dependency, so you can notice the projection of a, okay, that is a function. That is basically a function from this to this. This is the point. Is this clear to everyone? So what I'm saying is, okay, if you have this, then if you only project C comma D, if you only project C comma D, then you will get a function basically. Then we will get a function from C to D, from R dot C to R dot D. Okay, because this is the point. Here C will act as a primary key. Yeah, if you project it out, then yes, C will work as a candidate key. There can be multiple. Okay, it will work as a candidate key because it can happen. It is possible. See, it is possible that, let us assume A also implies B, B also implies E. Let's consider. Okay, let's consider another example. So let us assume you have this A, B, C, D, and in this A, B, C, D, let us assume that you have these F. I'm giving you two FDs. So let's assume that A implies B, and let us assume B implies A. Let's assume these two FDs you have. And now if you project A comma B, then what you are going to get? Tell me. Now if you project, okay, if you project A comma B, if you project now A comma B, then what you will get? Tell me what you will get now. Now you will get a bijection. Now you will get a bijection. Yes or no? Satyajit, not equal. They need not be equal. You will get a bijection. That need not be equal. For example, this is what you are going to get now. Now you are going to get this. For example, 2, 11. Now you can notice this type of thing you cannot get. Now this type of thing you cannot get. Okay, so you can notice this type of thing you will get. 2, 12, 4, okay, 4, 15, like this. So you can notice you will get a bijection. So if you have this type of situation and then you project, then what you will get? You will get a function. We will get a function which is a bijection. We will get a bijective function. Clear? Is this clear to everyone? Tell me. And Rahul, now you can notice here we have two candidate keys. Now you can notice here we have A is also candidate key, B is also candidate. Yes or no? Sweta, this is like in this example, consider in this example. Okay, consider this student example. In this student example, let us assume you have a student ID, you have a student name, you have your, let us assume you have, okay, let us assume you have passport number and let us assume you have passport number and you have Aadhaar card number. Okay, now if you project them, now if you project them, then what you will get? So now you can notice here, let us assume that, okay, so you can notice this will Aadhaar card number and this will imply this. Yes or no? So project number will, PAN number. This is your PAN number. I can say this is PAN number. So this PAN number will imply Aadhaar number. Aadhaar number will imply PAN number. Correct or not? So now if I project PAN number, comma Aadhaar number. If I project this PAN number, comma Aadhaar number, then what I am going to get? Then I will get a bijective function. Yes or no? If I project this, then I will get a bijective function. Correct or not? You will get a bijective function. PAN number, Aadhaar number. Okay, so now you will get a bijective function. Maybe okay, CD1121, and this, okay, this Aadhaar number you will get. So, okay, so like this CD1211. Like this, you will get a bijective function you are going to get. Anyone has any other doubt? Any other doubt, anyone? The final conclusion, you can notice that if you project out a functional dependency, then you will get a function. This is the final point. This is the conclusion. This is the conclusion that, okay, so basically in relation R, if we have functional dependency X goes to Y and we project and if we project X comma Y only, okay, then we will get a function. Then we will get a function from X to Y, from X to Y. This X and Y, they can be anything, remember. then we will get a function from x to y. They can be set also. For example, if you have this, let us assume your relation is ABCD. Let us assume this is your relation ABCD, and you have functional dependency. Let us assume that AB implies C. Now, if you project ABC, now if you project ABC, if you project A comma B comma C, then what you will get? Then we will get a function from AB to C. Is this clear? Is this clear to everyone? Tell me. Okay. So you can notice functional dependencies, they are one way. Actually, on one another, actually, this is another notation. This is another notation. This is not a popular notation, but actually this is given by a code in his original paper. This notation is also given by code in his original paper, let me tell you. So the concept of functional dependency was defined by code. Code was the person who defined the concept of functional dependency in his original paper. He has given this symbol also in his original paper. You can notice this is the screenshot from the original paper, and you can notice in the original paper this symbol is also given. This symbol, what it means, what it actually means, this symbol, this symbol, what this means that, so you can notice, if let us assume if A implies B and B implies A, means A determines B, B determines A, then we can write it that A determines B, B determines A. So this is a bijection basically. This is a bijection, or you can call it one-to-one correspondence. Clear? Is this clear to everyone? Example we have already taken. Okay, so this example we have already taken. You can notice here. Here you can notice the, okay, so PAN card implies Aadhaar number. Aadhaar number implies PAN number. If you know the value of PAN number, then you also know the value of Aadhaar number. If you know the value of Aadhaar number, then you also know the value of PAN number. So you can notice this is a bijection. This is a bijective function. I can also write it. I can simply write it. PAN number implies Aadhaar number, and Aadhaar number implies PAN number. This is another notation. Okay, this is just another notation. For example, this I can write it. This I can write it like this. So what this symbol means? This symbol simply means that this is just, okay, one-to-one correspondence. This simply means that this is bijection. Means one-to-one correspondence. One-to-one correspondence. Okay, is this clear? So this is the point. So far, is it clear? Basically, this word, I am just focusing on this word function, because in the definition, in the word, in the functional dependency, you have function. So a question can be created. The GATE exam, the GATE professor, they can create a question based on this word function. Yes or no? So something like they can do anything. Basically, this word function I am focusing on. Okay. So is this clear to everyone?